Good afternoon. Wonderful, wonderful to be here. Hope you've been having an amazing day. It's so, glad to see here. First time in Portugal, in Porto, so it's wonderful, wonderful occasion. How many of you are new to Porto? First time attending Porto conference? Excellent. Okay, quite a few. Right. So thank you so much for being here, for being at the conference, for this session. So wonderful to have you. My name is Sheen Brisals, and I've been in the industry for many years. I started as a software engineer back in 1991, and for the last 8-9 years, I've been kind of working with AWS, and in particular, the serverless technology. That's because my previous employer where I was working had a situation where they had to move out of the on-prem, self-hosted e-commerce platform. So that's how AWS, the cloud came into the picture. And then there was this situation where we didn't want to manage or go through the trouble of dealing with containers and servers. That's how the serverless became a thing. And I was one of the people who were pushing for serverless adoption. So when we completed that, the migration, 100% of the e-commerce platforms backend services were running on serverless. So that's the reason why I'm here talking to you about serverless, and also the reason why I wrote this book, which came out earlier this year with my then colleague, Luke Hedger. So that's available. And at the moment, I'm writing another book about speaking at conferences, which is due in February. Right. So let me start with the celebration. I know this is Nth year, so it's not at their anniversary, 10th year anniversary. Can anyone tell me, except Luciano, what this means? Why I showed this slide? Anyone? It's the 10th year anniversary of AWS Lambda. So AWS Lambda service kind of revolutionized the cloud ecosystem and the function as a service, and it's the 10th year this year. So, and also, I'm sorry to show you the next slide, which is not nice after I shown you the beautiful cake. So this one is the GenAI representation of ball of mud. I'm sure if you're a software engineer, you know what it means. So this is how we used to build, systems. Everything together, no care in the world. I mean, we can't blame ourselves because we didn't have all the modern technologies back then. So we had to work with what we had those days. And that also then brought us this one, what we call the lasagna architecture, where again, it was fine those days. We had software components, we kind of layered them, but behind the scenes, they created tight coupling. So it was difficult to untangle and everything was a mess. And then we got to this thing, right? So whatever we call, the name these things, these are realities of how we end up building software applications. Now, someone will say microservices. Solving all the problems, that's fine. And then cloud came along. Everyone said, yes, that's the silver bullet. Push everything to cloud, you'll be wonderfully fine. And then, of course, the serverless thing happened. Now, serverless, how many of you are new to serverless here? Completely new. Okay, quite just a few. So serverless basically takes away some of the heavy lifting from you so that you can focus on, building the applications. But the thing is, how we approach with these modern technologies matters. It's so simple for many teams or organizations to make a mess out of these technologies. So technologies don't solve the problem. Like if you are listening to the previous session, it's, the software engineering as an art, or, we need to know how to, do things. So for example, what happens with serverless is many teams start something very simple. They add one thing, then the second thing, and the third thing, they do the connections. So within the team, they do all the wiring up. Then they say, oh, my colleague's team over there, so I can reach out to the resource there and the department over there. Without realizing, we end up building a tangled architecture. So my goal of this talk is to educate you. If you are in this sort of evolutionary phase in your organization, don't fall into this trap. Technology is good, but understand some of the basic principles that you need to know so that you can build better software. So today's agenda is this. I'll briefly go through the serverless story or story of serverless, and then we look at why we think enterprise are complicated. Why always there is a special consideration when it comes to enterprises. And then briefly look at the patterns and practices, not going deep into the sort of design patterns that you may be familiar with. We'll probably stay a level high, and then we will wrap it with the takeaways. Now, the history of serverless, for example, the reason why it's important to understand is because that's how we can get into the right mindset. So going back all those 1950s or around that time, we had mainframe. I mean, mainframe is still around, right? Those who worked on mainframes became millionaires. That's a true thing. And then the virtualization basically kicked off the modern cloud revolution. Okay, so that's how we got to the cloud. And if we want to trace the serverless story, so we had mainframes, and then few developments happened from there until the 90s to make us to get to where we are now, especially the the networking and the virtual machines and things. The cloud computing term itself appeared way before cloud was a thing. And then from there on, Amazon and other tech companies started experimenting with infrastructure as a service or a platform as a service before things moved on. So for example, 20 years ago, one of the popular queuing services from Amazon, AWS, the SQS, Simple Queue service, it was beta was released in 2004. So that was basically a managed service, forerunner to serverless. Managed service in the sense that your cloud provider takes care of managing it. Similar to, say, you upload your photo to Photo Bucket or some cloud storage. All you want to do is upload your photo. You don't care where the photo ends up, how they store, how they replicate, how they duplicate, redundancy. You don't care. As long as you can upload, you can retrieve. So that's kind of the managed service ecosystem where the serverless technology is based on. So things moved on from there, and there's so many services came along from different providers, and the serverless term itself appeared even before Lambda was released. So that's how the origins of serverless and the Lambda happened, and then plenty of other services came along, API gateway, so on and so forth. Now, the reason why I say that is understanding serverless is important. For that, you need to first understand cloud. I think cloud, everybody knows these days. It's there by default, whether you are into LLM, GenAI, whatever. But the important thing is the change in the mindset from being a buyer to a consumer of services. So this is why the capital expenditure to the operations come into the picture, because you're not thinking of buying and installing and building your own stuff, rather than you consume. Even if you consume a container, basically that you get as a virtual machine, then you do your stuff on top. So that mindset is necessary when you work with serverless. So there are 4 things when it comes to serverless, 4 C's I say: characteristics, capabilities, considerations, and collaborations. So let's briefly look at characteristics. Characteristics in the sense the properties of serverless. As I mentioned early on, it provides us the platform to do awesome things because some of the heavy lifting taken care by the cloud provider. That's fine, but there is more to it. Because if you think of iterative development, that's so common these days, right? Agile iterative development. You do part by part. Serverless is an amazing technology for that because you don't need to provision or buy, 100 queues or 1,000 buckets in advance. You just consume as you need for your next iteration. So that's how it goes. The other beautiful thing I always insist is it brings diversity into your engineering team. So that means you're not going there working in serverless purely as a programmer. You are becoming a software engineer knowing many things. For example, you need to know how to secure your services. What is the least privilege principle? You need to know how to queue things. How to work with, if you work with the NoSQL data store, you need to understand that. So you become kind of fully diverse in everything around building software applications. And then with the characteristics, you get the benefits of using serverless. So this is another area where organizations or teams benefit from. And as I mentioned, the iterativeness and the diversity and things, it's also true that optimization, for example, you can go deeper. For example, you have, say, 2 queues. You can optimize, you can tune the 2 queues separately, completely separately, same as 2 functions. You don't need to go with the one-size-fitting-all scenario. You can completely go deeper and tune as you need. And this is the most important aspect when it comes to serverless. This is where teams, big and small, make mistakes. They just underestimate and just think that everything will scale perfectly to indefinitely or whatever they like. It will be cheaper forever. No. This is where you need to understand, okay, what are the limits of this technology? They say serverless, it scales, etc., but there are quota. There are limits of throttling. How many API calls you can make on a particular service per second or a day or a minute. So this understanding needs to be there in order to make use of the capabilities effectively. So this is an important aspect. Then comes the collaboration. So collaboration is a socio-technical thing. That means, though as engineers we work with technology, we don't simply deal with technology. We also deal with the people and the processes around it. So this is what you probably know these days known as systems thinking. Right? So there's a book, if you haven't read, it's a good book, especially if you're working in the modern cloud technologies by Diana. It talks about system thinking. What it is it's also people, processes, and technology and all the elements around it. When it comes to serverless, I've been saying that for a while, that serverless technology is actually an ecosystem of many things. Because it has cloud as the foundation. Then you have all the managed services on top. Say, for example, the queues or the databases or S3 buckets, so on and so forth. Then you and I as engineers, we build solutions using tools, frameworks, and things. So they become part of our ecosystem. Who do we build for? For our stakeholders. Why are they asking us to build things? For customers. So all these people are, one way or the other, part of the whole ecosystem. So that mindset should be there when we work with technology like serverless. Because serverless application, when you build, you are basically bringing together available managed services and kind of wiring things up or knitting things together with infrastructure as code. So that's kind of the way to think how you build applications with, with serverless. Now, let's briefly look at what's the fuss about enterprises? How many of you will say you work for an enterprise? Just a few, okay. Now, I don't know your definition of enterprise. If someone asked you, define enterprise, I don't know what answer will you say. There are different ways. One way of saying is scale. I mean, like many words in English, scale has bunch of meanings. You can talk about fish scale. You can talk about sort of chemical reaction scaling. Whereas when it comes to enterprises, scale is basically the magnitude of things, like a large scale, the industrial scale we talk about. And with cloud, we have the cloud scale. Again, the definition is to show you, the breadth and depth of things. When it comes to enterprise, we say enterprise scale. The reason why we say is because of all these different things associated with an enterprise. So it's not just employees. Even if you take employees of an enterprise, there are engineers, there are HR people, there are stakeholders, business, etc. And then the products, there are a bunch of products, technologies from say mainframe to on-prem to cloud to AI and all sorts of things. So there is a mix of all these things, plus the policies and the regulations and the distributedness of the locations, like teams. You don't see people, you don't speak the same language, and all these complexities are there when it comes to an enterprise. But when it comes to enterprise applications, they have different needs. You are expected to have all these abilities when it comes to enterprise scale applications. Cost probably is not even there. That is also part of it. All these abilities, how do you, cope with everything? It's easy for someone, on Twitter to say that all you need is a single server to run your business, and that they will get millions of likes. Just think about it. The two most expensive things in software business, first one is salaries, right? They need to pay us. Second one, anyone can guess? If you're an online business, if you have computing, yes. But also critically, if you are running online business, the expensive thing is downtime, right? If, say, Black Friday, if your website went down, you can count the hundreds of thousands or millions of revenue lost. So this is why enterprises put up redundancy. They set up a duplicate server somewhere else so that it can fail over and take over. So see, already you are duplicating. It's not a single server anymore. Then you need to think of the traffic patterns and the lows and highs and all sorts of things. So it's easy to say that, oh, you need only a single server, but when it comes to reality, if it's your business, you know how to take care of all these abilities. And then couple this with the modern way of operation. We are moving so fast. How many engineers here would say, or engineers or your teams, that you deploy, you release to production once a week? Okay, just 2-3 hands. How many do a release per day? Okay, few, very few. Teams do multiple releases to production every day. So that means they go through this on the other side. So that is the way, the fast flow and the velocity of modern teams. So anyway, so that's the complexity that we are dealing with. Now, how can we bring a new technology into this mix? Okay, it's not like you bring serverless or cloud and head first and do everything. No, you need to think, you need to take a step back and apply certain principles before you dive deep. So that comes to the problem decomposition. Has anyone read this book? There's a beautiful quote here. In computer science, problem decomposition is the biggest problem because engineers, as engineers, we struggle to decompose problems. It's true. Whether it is an engineering problem or a business problem, it happens. Let me give you an example. Who can tell this scene from? Which movie? Mamma Mia. Wonderful movie, right? Full of color, laugh, and everything. But behind the scene, to bring those, what we see on screen, there's so much complexity goes behind in producing a film. But how do they deal with? How do they do that? How do they manage the complexity? The answer to that is basically in a dialogue from the same movie between these two people. For one person, everything is complicated, nothing is simple. For the other person, it is simple if you break it down. So this is what they do. In movie making, what they do is they identify what they call set pieces. Set pieces are kind of, special scenes or a climax or a car chase or an emotional scene or whatever. They identify that and then they plan to film that. So for example, we can say that in the movie there are a few scenes. So these could be set as separate pieces and they bring together and they connect via dialogue, music, background, etc. So basically a set piece is a scene or a sequence of scenes, and that requires planning before you kind of do the actual filming. Similar to how we build software. We do identify part of the problem, we then develop it, test it, and push to production. So let's look at how can we decompose problems, bigger problems. Now, how many of you read this book or any variant of this book? Wow, just 2 or 3. I'm disappointed now. Now, so DDD is not everyone's cup of tea. That's why there are at least a dozen or so other books that tells us about DDD or teaches us DDD. And I often joke that this is not just a book, this is an industry, because there's a dedicated conference, there are training courses and books, there's a kind of $1 million industry behind the simple blue book. Now anyway, what that gives us is the way of dividing your organization into domains. Okay? So whether it's whichever is your domain, like e-commerce or insurance or retail, whatever. Then once you have identified your domains, you can have subdomains. So you're already kind of splitting things. Like for example, if you're an insurance company, you can separate the quote generation from insurance sale or insurance claim. Okay? So you have that separation already brought in. Then one of the important aspects is identifying the boundaries. Bounded context, many consider as a complicated thing to think about. It's basically an area where a particular software model applies. So if you take this model and put somewhere else, that may not make any sense. So for example, the definition of a customer, especially in the rewards, the bottom one, it may not be the same if you put the same customer in quote generation, for example. So that's basically the bounded context. The idea is that you are getting into a small definable area of your system. Once you have that, then somebody else can take over. Team topologies. Team topologies, I don't know if you're not familiar, it basically gives a flavor of how you can structure your teams for efficiency and fast flow. Now, how does this help? So with a bounded context, now you can bring team ownership. So that means if rewards is boundary, then you can have a team that looks after that part of the system. So simple, right? So you have multiple teams. And so when I said team topology, so these are the four the team types mentioned in the team topologies book. So enabling teams is like you are a small team. Basically, you enable other teams to do things. You do kind of take care of certain toolings or processes, CI/CD pipelines and things like that. Platform team is not necessarily the cloud platform. It could be any platform. Basically, you are doing that service so that other teams can consume what you provide. Anyway, so once you have this, then it's time to bring in these amazing microservices or something equivalent to what you do, how you do in your thing. So that gives you the independently deployable single-purpose services, right? So if you add these things, add microservices into the boundary. I'm saying microservices, it could be other applications or how you bundle your software, right? So for the conversation, it's easier, so I'm adding microservices. See how things go now. So you're broken down, decomposed from the top, and you have smaller areas where you have authority to control. You're not kind of crisscrossing, overlapping things. You have clarity. And now you can bring in more things on top. So putting all these three together, if you haven't read this, I highly recommend reading the three books at least, if not team topology, just the DDD and microservices. Now, we have come to a point where we have some kind of control. Now we can think of applying the architectural and design patterns because you know exactly. Because this is the reason why you don't see modern teams. So if you go to a modern organization structured this way, you don't see big architectural diagrams spread across the entire wall because there isn't like that. Because teams, they own the architecture. They kind of do things. Right, so first thing is event-driven architecture. I know there is so much noise going on in the industry. The moment someone says event-driven architecture, you know what? Immediately you hear this one. It's so complicated, everyone jumps out. Do you know the most complicated thing in the world, according to many? Anyone? Sorry? Human body. According to many, this is the most complicated thing, but we manage it beautifully, right? To click my clicker, I need to get a signal coming from. This is again event-driven. And we built amazing things for years, and we are operating them. Say, for example, take Airbus A380 and the cockpit and all the things behind the scene. We operate without making any fuss. But when it comes to software engineering, the moment we need to draw a few lines here and there, we say everything is complicated. No, I can't manage. It's so difficult. That's the mindset. So anyway, complexity exists all the time. There are two ways to look at complexity. One way is accumulated, and the other side of thing is distributed. Say, for example, this cube. You can immediately think, oh, that's a monolith. Could be anything, right? Or you can have something else. But thing is, it's hiding the complexity inside. It looks so fine. It doesn't matter where it's a monolith. You can even build a macro service with all the tangled stuff. On the other side, though, you see distributed things. Like I mentioned, the boundaries within your department or across your department or across your organization or multiple organizations. They are distributed. They look complicated, but they are, simplicity inside. So that's what I'm coming to. So on one side, when it comes to accumulated, it looks simple, but complicated inside. Whereas when it comes to distributed architecture and most of the event-driven cases, its complexity is visible outside, but if you look at inside, each service has its purpose, and has its boundary, just like what I mentioned early on. So, like I said, complexity is always there. Now, if you are familiar with the cell architecture of the past, it's basically coming back. So there's an article, recently I noticed an article series on InfoQ, if you are interested, worth reading. It kind of brings the cell structure to how I define the boundaries and bounded context. Because with that, you can easily identify critical services with non-critical services. You can kind of clarify which is the back-end process, which is facing the customer. So that way you know if this service went down, your business is down. If this service is down, you can still carry on. So these sort of separations and clarity is essential in modern days how we operate business applications. So when it comes to event-driven architecture, I think a couple of years ago, this is Werner Vogel's CTO of Amazon. He said this thing, everything is asynchronous and event-driven. That is true. So just to give you a quick flavor, if you are new to event-driven architecture, this is a quick introduction. Say two services, service A and B. And service A is basically, say you are on a website asking for a price. So when you ask the price, you should get the price back synchronously because you're there waiting. Same thing, you want to drop something into the basket. And take another example. Here there are two services. One service is submitting a batch of things for service D to do. So it's not going to complete the job now, it will take time. But who knows how long it will take. So it will provide an acknowledgement with some kind of identifier for the client to keep track of. How does it keep track? Probably service D provides a mechanism to query the status. This is simple CQRS, if you are familiar with the command query pattern, okay? Now, looks fine, right? But C has a problem. Not one, 3 problems. How soon should it start polling after submitting a batch? How often should it poll? For a day, for an hour? Don't know. How often and how long? So these 3 things, C's problem to worry about service C. So what if we change it to have the same things, but in this case, D is emitting events as and when it processes things. So that is, in a simple way, saying event-driven, because it's emitting an event for the other consumer to know, what happened. So the same way you can do with, queues to decouple systems, and these are also, known as the the asynchronous event-driven operational constructs. So basically, event-driven architecture is communicating with events and doing things asynchronously. There is so much power in the event-driven architecture, especially when you come to distributedness, because you're not expected to do everything there and then synchronously. So that allows your business to be flexible and cope with some of the stressful situations or failure scenarios. So some of the core elements of event-driven architecture. So there should be a publisher who will publish an application, who will publish events onto some kind of a broker or an event bus, and there will be consumers on the other side. So they will be interested to receive certain events. Not all events will go to all consumers, but that's where they choose what do I need to know, and then it can act accordingly. So basically the 4 elements like producer, consumer, event bus, and the event. So events, if you're new, it's basically something happened in the system. It's not new. It happened, the age-old days of the whole, the computer software, the computer system, operating CPU, everything, all event-driven. So it's not new. However, what happens is often teams take this lightly when they define events. So this is, again, I stress that When you are looking at events, think of a structure that everybody can follow in your organization or in your department. So for example, this is Amazon AWS Event Bridge pattern, whereas on the right-hand side, something I propose that break it down into metadata, typical metadata data section. So that means it allows you to pack things about that event in your metadata. See now, if you look at the details, you can think from the decomposition I mentioned, which domain is coming from, what is the subdomain, which is the boundary, which service, etc. So these are all informations useful for a consumer to act accordingly. You can even supply TTL, for example, how long the consumer should maintain this event. For example, in a retail situation, if you have a, 100 days refund policy, consumer like, order fulfillment or something, they can't simply ignore it. They are supposed to retain it until that period, expires. So these are the informations you can pack into an event and make it a structure so that everybody can adopt in your organization. So the data part is simply, the instance of the data. I want to tell you two patterns when it comes to event-driven architecture. Two, sort of high-level important patterns. First one is choreography. Does anyone know choreography? Pattern as a pattern? It's basically originated from choreographing dance movements. In a sort of a dance troupe, you teach people how to dance according to the music, but you don't instruct them when the music is played. They listen, and different people in the troupe, they will dance accordingly, right? Same concept, like I mentioned earlier on. You have an event bus that is like, streaming the events, and the consumers, as they receive the event, they know exactly what to do. If an order fulfillment service is receiving an event about order, it knows, okay, I need to now ship the order to the customer. Or if the payment service, it will know that, oh, now we are ready to ship, I better transfer the fund or the money. So that's how the orchestration happens. So here is an example. I'm not going to go through the details. If you look at the middle, there is a product registration app. Just imagine that when you register a product that you bought, like a, vacuum cleaner or a dishwasher, you get some points, loyalty points. So that means your loyalty microservice on top is interested to know so that it can update the customer account. And say, for example, when you register a product, you get, 10% discount for your next purchase. So that means somebody is looking after the promotion will generate an event about the discount that another service will take care of emailing to the customer, for example. So this is roughly how the orchestration situation will work in a sort of a microservices, serverless architecture and application. So some of the key points to consider if you're completely new is basically coordinating between microservices or applications. There is nobody instructing, but there is the transporter or a broker or a bus, however you call it, and it helps decouple. And also you need to think of idempotency. Idempotency is like an event may arrive more than once. That means the consumer should take care of dealing with that situation. You can't simply grab the money twice from the customer account. So these are the things that, the engineering problems we need to kind of think of. Second pattern that goes along with orchestration, the choreography is orchestration. So again, originated from orchestra, where there is somebody conducting the troupe, right? So the instruction happens from the orchestrator. So again, here, there is an orchestrator will inform, okay, hey, now you store this data or you push this event to that application or something like that. So for example, in a simplistic term, if you must be familiar with the workflow or a flowchart, for example. That is a representation of an orchestration. Then you have cloud providers providing services. Say, for example, in AWS, there is something called AWS Step Functions. That's an orchestration service. So that allows you to connect with or work with multiple applications, sending or invoking accordingly. Now, when it comes to orchestration, this is an area where teams often get it completely wrong. So I usually propose 3 types. Again, for clarity and keeping things separated. The first one is in-service. In-service is, if you have a microservice, you orchestrate everything within the microservice. Cross-service is you can go out, but you go out via defined API contracts and things. And then distributed is going across multiple domains. Let's quickly go through that. And in-service orchestration. So basically here, what you see is you have a domain, you have a microservice, and within the microservice, you have the orchestration. There is nothing going outside of the service. Everything is within. So this is good in so many cases. This is the recommended approach. That means you're not making tight coupling with another service or a different cloud service out of the blue. So the other one is cross-service. So cross-service in the sense, same, so you have microservice, you have the orchestration inside, but the interaction happens with the outside systems via, say, APIs or events. Again, you avoid tight coupling between these different systems. Okay. Now, let's quickly look at the third one. This is kind of complicated if you are new to orchestration. Say 3 domains here. Domain A, there's a microservice which has an orchestration. So let's say that's the primary orchestrator. It requires the 2 other services or domains to fulfill some job. Say, for example, someone raised an insurance claim. You imagine how many hoops an application has to go through before you finally do a payout and things. So some services may take hours, some may take days or even weeks. So how do you do that? So there are possibilities with cloud services these days. You can keep things separated, but you can interact via events. So that means you have an event going out onto an event bus and consumed by the other service. And then you pause the orchestration, and it continues when the event or the response comes back. So I'm not going through the details because it's beyond our discussion here. So this is another way of keeping things isolated, separated as much as possible. Now, let's move on to development practices. Sustainable development. So sustainability, you know that you talk about green energy, low carbon, etc. So if you've been in the industry, you know the waterfall model, right? So where requirements comes, you go all the way until you push into release the product, and then it goes into some sort of a maintenance mode, okay? And that's pretty much the end of the story for that application. But modern days, we don't do that. We sustain. What I mean is, say you have an idea. You start a simple iteration. And then you push production, you operate. What you do, you sustain and take the next iteration. So you are all familiar with this terminology called MVP, right? Minimum viable product. You start with that, and you do another MVP to make it a maximum or most valuable product. So this is the journey I'm talking about, sustaining it. So you're not kind of doing everything in one go, but you are kind of keeping it going. So that's the beauty of modern application development, especially with serverless, as I mentioned early on. So when it comes to sustainable product, you can't simply do this without proper thinking. So you have to have sustainable product. You have to develop. There are 3 primary characteristics when it comes to sustainable product. One is modularity, extendability, and observability. So these 3 things, if you take care, you can build, sort of the sustainable applications. Because if you build modular applications, you can make them extendable. And observability is core of everything, because observing, I always say that observing activities in a small pond is way simple and easier than looking over the ocean. So that's kind of the mindset we need to have. Right, so that's one thing, that's the development. Second thing is solution design. I know in the previous talk there was something about the architecture. So solution design is basically, you may be doing in your organization, it's thinking before you start your development. Things like you look at, okay, what's the logical design, logical architecture that you can discuss with your stakeholders and business people. And then you look at your architecture, you look at your design details, and then data structures and event structures. You think of sustainability aspects. How can I reduce carbon emission if I lower the performance of this particular service, which only runs in the background, is not impacting customers? So that's sort of the thought process. And plus the cost implications, how to, upfront have an idea about how much you will be spending. Without that, you can be, spending a fortune and blaming the technology. So basically, it brings all these, abilities. Clarity, it becomes, gives you the clarity, and, it takes your service for longer. So blog post I wrote a while ago. Another thing, when you work in serverless or cloud, is the knowledge of threat modeling. Anyone familiar with threat modeling? Do you do in your organizations or in your teams? Cool, good. So there are different ways, again, to do that. One of the popular ways is Stride. Stride is, I think it originated from Microsoft and stands for the first letters. So again, when you think upfront and when you produce a document, you are basically thinking of, okay, what are the possible attack options for this application? How can I mitigate? Who can attack? Who are the attackers, inside and outside? How can I mitigate? How can I prevent them? So this thinking comes up front. So if you are new, read this book. It's an old book, but it has a good details about threat modeling and how to do. And so again, I have written a blog post and takes care of these things. And another important thing is cloud account separation. So this you will understand now, because I've been through the decomposition. Say, for example, you have a bounded context, that is rewards. So you have a team. This is an autonomous team responsible for this thing. So they build and maintain those microservices, part of the bounded boundary. That's their boundary. So that means you should think of operating these services in dedicated cloud account. So that is the cloud account separation. So it will bring bunch of benefits. If you're in the organization moving to cloud or already in cloud, think about it. So that means if we have multiple teams, they can all operate with their different cloud accounts. So it brings tons of benefits. And also it allows for teams to vary. So for example, one team needs an extra environment, it's fine. They don't need to impact others. And let me finish with the final one, automation and fast flow. So let me bring back the diagram I showed you earlier. So the focus here is this one. So I mentioned this is how the modern teams operate. But how is it possible? So in our book, we call something like square of balance to reiterate the importance of this thing. What that means is, when you have an increment or when you develop something, it goes through the PR process, etc., you do the testing, you release that. As soon as it's gone to production, you're observing it. If something is going wrong or gone wrong, you are thinking of recovering it. And the cycle is always continuing, okay? So new PRs coming in, new testing, releasing. This is where the automation, the power of automation comes. And also, this is where you make trade-offs. You differentiate what's your critical, the most critical part of the system. You focus all your testing there, and you can be a bit relaxed on the non-critical aspects. So this is like going against the 100% test coverage syndrome. Some cases, it makes no sense at all. You need to focus mostly on the critical. If that's down, your business down. So you must guard against. Whereas some parts, you can be a bit relaxed. If it went down, you can kind of recover. So this sort of thinking process, you should keep in mind. Right, so let's wrap it with the key takeaways that we've been through. Serverless, understanding the whole ecosystem is essential. Then recognizing the scale or the complexity of enterprises. I'm saying that because there are teams that undermine this and get into lots of trouble. So that's why always enterprises need extra attention. Then, of course, the patterns and the practices. You go through the learning process of putting certain things. Not all organizations are decomposed perfectly with domain-driven design. There are ways to do that. It takes time. It takes buy-in from everyone else. I mean, there was an earlier talk about self-organizing teams and how they discuss as a group all these things. So these are all the practices that teams and organizations should think of while adopting modern technologies such as the serverless and even AI now is shaking the whole organizations or enterprises. So I leave you with this phrase. So this is how we are now kind of going every day, day to day. Yesterday always becomes legacy. So we are like learning everything today to prepare us for tomorrow. So this is where the modern technologies, whether it's a cloud, serverless, AI, gives us the the wing to fly or the acts as a slingshot. Thank you all so much. Absolutely pleasure here. Enjoy. Enjoy the rest of the conference. I'm around if you have any questions. I think I'm running out of time. So, please find me and happy to interact or advise or whatever. Thanks again.